morning and good afternoon, and welcome to the December Pacific Northwest DEWS Drought and Climate Outlook webinar. My name is Britt Parker, and I'm with the National Integrated Drought Information System at NOAA. This bi-monthly webinar series, hosted by Nidus and the USDA Northwest Climate Hub, as well as the Oregon Climate Change Research Institute. It is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect the recent, current, and forecasted conditions and climatic events, but will also include discussions of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week, and if you've registered for the webinar and are here, you should get an email to this effect. Note that after today's webinar, you'll have the opportunity to provide feedback that will help us improve this webinar series over time. So please take a moment and tell us what you think. Today's speaker includes Karen Bumbaco with the Office of the Washington State Climatologist to give us the climate recap and current conditions. Andrea Baer with the NOAA Weather Service Western Region to talk about the seasonal conditions and climate outlook. Heidi Huber-Stearns with Oregon State University will talk about smoke-ready communities. And then Chris Gomans from Colorado State University will talk about an analysis of the impact of drought on agriculture, local economies, public health, and crime across the Western United States. We will be using the Q&A box at the right side of your screen for questions during the presentation, and we'll address those and additional questions during the Q&A portion after the four speakers. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops and delivers science-based, region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. Visit their website to get more information. The Oregon Climate Change Research Institute is a network of dozens of researchers in Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University and advances understanding of regional climate, impacts, and adaptation, and cultivates climate-informed communities. Nidus was established in 2006 by public law with a mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. Nidus is building the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their regions. The Pacific Northwest DEWS was officially launched in February of 2016, and our strategic plan and information on current activities is available on drought.gov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CocoRoss, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as other condition reporting. Observations by CocoRoss observers of precipitation events or the lack thereof are important to capture and improve our understanding of weather. To become a volunteer or learn more, visit cocoross.org or contact your state coordinator. I'll put the names and emails in the chat box after this presentation. For news from around the region, we wanted to flag that the National Climate Assessment is a major U.S. government report on how climate change affects people and places in the United States. There will be a series of regional and sectoral engagement workshops to inform the 5th National Climate Assessment starting in January. I will put the link for registration for these engagement workshops in the chat box after the presentation, but please note there will be a Northwest engagement workshop on February 1st, and the information shared at these workshops will inform the authors on which topics to focus on in the report. So you can note perhaps sectors you're interested in as well as regions. We also want to flag that facilitation guides are now available for the Climate Resilience Workbook series. Check these out on the Climate Impacts Research Consortium webpage. The guide enables individuals to guide members of their community or other entity through the process detailed in the 3 climate resilience workbooks: the use of the climate toolbox, vulnerability assessment, and planning of resilience actions. For each module in the workbooks, the guides include model agenda, facilitators agenda, presentation materials, and guided exercises. And I will again put the link in the chat box after the presentation is done. Finally, the U.S. Drought Portal has released drought email alerts. Get updates delivered to your inbox. Sign up for drought alert emails for the U.S. Drought Monitor for your location, which includes the number of weeks your location has been in drought according to the USDM, the current Climate Prediction Center monthly outlooks for your location, and links to submit local impacts to see more and tweet about drought. You can also get alerts when the Climate Prediction Center releases the monthly and seasonal drought outlooks for your location. And again, I'll put a link in the chat box after this presentation. So with that, I want to hand over the presentation to Karen, and we will start into our first presentation today.
Okay, good morning. Can you see my screen and hear me okay?
We can, thank you.
All right, fantastic. Well, thanks for joining this morning. I'm going to recap conditions going back to September, because the September through November, or what we call meteorological fall, did set some records throughout the Northwest that I wanted to highlight. On the left-hand side here, we're looking at our temperature anomaly for September through November. And what jumps out at me on this map is Montana and Idaho in terms of the redder colors showing how warm it was during the fall there. For Montana as a whole, it tied 1953 for the second warmest fall on record. And then Idaho, average statewide, tied as the 6th warmest fall on record. Washington and Oregon on the warm side for sure, but not really notable in terms of the records for fall. However, for precipitation, which is shown on the right-hand side, that's the total precipitation anomaly for the fall. Washington was quite wet, averaged across the state. It was the 6th wettest on record with 143% of normal precipitation. And this area here in northwestern Washington really got the bulk of that precipitation. Some of the stations in Bellingham, Seattle, Quileute on the coast actually had their wettest fall on record at some of those individual stations. The rest of the Northwest, near normal to a bit on the drier side, especially for Montana, and those statewide records are not so notable because of that averaging. So looking at just November as a whole, definitely warm across the entire region. Temperatures again on the left, lots of reds, especially in Montana and Idaho. Oregon, it was the 6th warmest November on record, Montana the 8th, Idaho the 8th, and Washington the 13th. These records go all the way back to 1895, so quite some time there. I should also note these maps are all comparing the anomalies to the new normal, so the new average of 1991 to 2010. So for example, when I first saw the Washington statistics, I was a little surprised that it was the 13th warmest with an anomaly only 2.8 degrees Fahrenheit, greater than normal, but that is the newer normal, and we're in a changing climate, so we're warmer now than we were, so this anomaly might not look as extreme as if you compare it to like a 20th century average, for example. But anyway, so for precipitation, definitely some large regional differences across the Pacific Northwest. I'm of course biased towards Washington. That was really the wettest part for November, ranked as the 18th wettest on record across the whole state. Northern Idaho, Northwest Montana on the wet side, and much drier in the southern part of the region for November. So since I am in Washington, I got a lot of questions about our recent wet weather and asking whether this was La Nina. So I did want to just show a quick snapshot of the November 500 millibar geopotential heights. So this gets at the anomalies. This gets at the circulation that we saw for the month of November, which is on the left-hand side here. These hot colors represent higher than normal heights, and the purples and blues represent lower than normal heights. But the main take-home message here is that we really had anomalous southwesterly flow directing precipitation, and just so happened 5 atmospheric rivers at Washington during November. This pattern over here is a composite of La Niña winters, and this is not or what we saw in November was not a La Niña pattern at all. Typically in La Niña, we have anomalously northwesterly flow. So the wet conditions in Washington, it was almost like we got the right answer for the wrong reason. It wasn't necessarily a La Niña pattern, but we did have quite a few atmospheric rivers that brought precipitation to Washington state. And we did see flooding. Most of you probably saw this in the news. We had kind of 2 periods of really wet weather in Washington. First, the set of 2 atmospheric rivers in about mid-November, and then a second set at the end of the month of 3 more. This is flooding taken from the city of Bellingham from some drone footage that was really astonishing to see. And then these are 2 rivers in northwestern Washington, the Skagit River and the Nooksack. And in that middle of the month period, we saw major flooding on both rivers. And then again, later in the month, it got up to minor or moderate flooding. And this, there was flooding on many rivers, not all to the extent that we saw in northern Washington, but also in northwest Oregon too, saw some flooding during this period. So December so far, it's definitely been on the warm side. Temperatures on the left, we can see a bit warmer anomalies, quite warm in Idaho and Montana compared to the rest of the region. Precipitation, a bit of a mixed bag, but mostly on the dry side. It's only been 12 days so far of December. So we'll, of course, keep our eye on conditions to see how the rest of the month turns out. So the unfortunate side effect, of course, of all this warm weather is that our snowpack is not in great shape, even in Washington, where we had wetter than normal conditions. It was so warm that most of that fell as rain in the mountains, and hence why we saw so much flooding throughout the state. But we did pick up a little bit of snow this weekend. These are percent of medians, again, based on the new normal, 91 to 2020. So we have seen some improvement. Northern Cascades especially are looking good. Some of the west slopes of the Oregon Cascades, a little bit better here in northern Idaho. This was just over this weekend. But of course, I am concerned about the lack of snowpack. In Washington state, for example, I just had a colleague crunch some numbers that we usually get between about 40% of our snow water equivalent in November and December. So it is concerning that we are running behind. But on the other hand, we do still have a good amount of winter left. I did want to show the soil moisture because, especially for Washington, there's been a big improvement west of the Cascades, of course, where all the flooding is, but even in eastern Washington, where we have seen drought conditions and where drought conditions were especially bad this past summer. Not so much improvement throughout the rest of the Northwest. I did want to point out, oops, go back. This is a NRCS soil saturation plot for Lind, Washington, which is about where this star is. And you can see a huge improvement just over the month of November with the precipitation we had in Washington. So those observations are verifying what we're seeing on the GRACE satellite there, and is hence why we have seen more improvement, I think, in Washington state compared to the rest of the Northwest DEWS area. This is the current drought monitor that was released on Thursday. So much of Western Washington is drought free. Seen some improvement throughout the rest of the region too. And you can see that better on this drought monitor class change for the last 8 weeks. So this is going back to about when we had our last DEWS webinar in October to last week. So overall, oops, there has been some improvement in the region. Most of that improvement has occurred in Washington and Idaho. So just to summarize, it was generally warm and wet fall, September through November. Temperature-wise, more anomalous in Montana and Idaho, with second warmest and sixth warmest falls going all the way back to 1895. For precipitation, most notable is Washington, which ranked as the sixth wettest fall. November was especially warm for the entire region, ranking between the 6th and 13th warmest for each of the 4 states. Precipitation was mixed, with most of that precipitation occurring in Washington and causing flooding. Heavy precipitation in Washington and parts of Oregon led to major November flooding. We can't put the blame on La Niña for that one. Snowpack is subpar throughout the Pacific Northwest with a few exceptions, and we have seen some improvements in the Drought Monitor, mostly in Washington and Idaho. And the one thing to note there is that the improvements in Washington are mostly due to increased precipitation and not so much where the snowpack is at this point. So that's all I had for now, and I'll pass it back to Britt.
Great, thanks Karen. And I'm gonna go ahead and give Andrea control of the slide deck. There you go.
And I will get this in presenter mode. Okay, Britt, can you hear me and see my slide? Okay.
Yes, looks great.
Okay, good deal, thank you. Thanks, Karen, for the great setup. So my name's Andrea Bear, and I'm gonna give you a quick look at the climate and drought outlooks. Karen mentioned La Niña. I'm gonna talk a little bit more in depth about that, but here's the typical La Niña wintertime pattern with that jet stream shifted a bit north, and typically wetter conditions in the Pacific Northwest and cooler, especially as you go further into Montana and the northern plains. But as you know, that doesn't always happen. This is just a typical pattern. So it's kind of like it's not quite like a snowflake. You don't get, they aren't all unique, but we definitely get some unique La Niñas, and they don't always go with what we typically see. So the status of La Niña, we are in a La Niña advisory from the Climate Prediction Center. That means La Niña conditions are present in the Pacific Ocean, and the sea surface temperatures are below average. I'll show you about how much in just a minute. And both the atmosphere and the ocean are playing nicely together, so we do have a pretty good La Niña going at this point in time. And it's favored to continue through this winter and then transition to ENSO neutral sometime in the spring, likely the April, May, June time period. I wanted to show this graphic. This came out recently on the climate.gov ENSO blog. And one thing that we are experiencing, as you guys probably note, we are currently in a double dip La Niña, or a second year La Niña. If you look at that thick blue line, that shows you La Niña's, or excuse me, the conditions starting in June, July, and August of 2019, and then going through to currently where we're at the end of that thick blue line. And you can see we're starting to dip down again, and we are in our second year of La Niña. An interesting thing to note about this, you know, you can't really use this as a predictor. There's only about 12 cases in here. What's interesting to note, though, is of the 12 first-year La Niñas on record, we have had 8 of those be double dippers, or second-year La Niñas, at least. Only 4 have lasted just 1 year of this sample size. And then 2 of those were 3-year La Niñas. So I don't know, that is a possibility, but just to kind of give you an idea of the range of possibilities. All right, so looking at current conditions, where I have that brown circle down there along the x-axis, which is longitude, that shows you that the East Pacific has definitely cooled off the anomalies for the sea surface temperatures since November. they've been cooling off quite a bit as you move farther east in the Pacific. So that just strengthens the sea surface temperatures and increases our chances for keeping that La Nina around. And then this shows you the different areas or different blocks that we look at for El Nino and La Nina. And if you look at that small map on the bottom left-hand side, that sweet spot there is what we call Nino 3.4. It's a combination of the Nino 3 area and the Nino 4 area. I have a blue arrow where Nino 3.4, the weekly average is down to negative 1.1. So our threshold to go into a La Nina is negative 0.5. So we're well above, or well below that, excuse me. And as you can see in this second graphic here, Nino 3.4 region is definitely quite cool right now. Looking at the subsurface, so from the surface down to about 300 meters, you can definitely see below the surface that we do have a nice cool pole going down there as well. From about mid-October through currently, we have weakened those negative anomalies a bit, but still plenty of cool water in the subsurface to keep this La Nina going. Looking a little bit at the forecasts, these just came out. These are the early December forecasts that are done with the International Research Institute and our Climate Prediction Center. And as you can see from that blue bar, 100% probability because we're actually in the La Nina event right now. But keeping that La Nina event going until you start getting into spring around this March, April, May season, you get about a 50% chance, flip of a coin there, of either keeping La Nina conditions or moving into neutral. But once you get into the April, May, June season, we're favored to transition to ENSO neutral conditions. And this is another look at the model predictions. This is just the various dynamical models, which are in the squares that are filled in, and then the statistical models, which are the circles that are hollow. And you can definitely see a majority of the models keeping us in La Nina conditions, again, through to that March, April, May, and April, May, June, those spring seasons. This is a very busy slide, so don't get caught up in the details here. I like to show this one. I showed this one last year when we were getting into the La Nina for last year, but what my point of showing you this, precipitation is on the right and temperatures are on the left. And it really drives home the point that we do have general tendencies for La Nina, but there really is a lot of variability. So, you know, definitely you can't say, hey, definitely we're gonna have this or that. There's a lot of variability in the various La Ninas. So this shows the last 20, and it includes strong, moderate, and weak events. So really, if you keep your eye on the Pacific Northwest there, you do see a lot of years where we've got wetter than normal conditions, cooler than normal conditions, but you see the opposite as well. So this also came from the climate.gov ENSO blog, and this was a recent post, and this shows the variability during those second year or double dip La Nina winters. And again, you know, there's only 7 cases here, so don't make any kind of prediction out of this, but it shows you the varieties that we've had in the past and the ranges that we've gotten. And while we have had in the Pacific Northwest, we have definitely had our wet years, there have also been dry ones. So which doesn't bode well for the drought, but hopefully, as Karen mentioned, it wasn't La Nina related, but the nice start that you all have had in the winter definitely helps. This is a graphic out of the California Nevada Applications Program. It's a RESA, and they basically did this before the new climate normals have come out. But it shows you the composite snow course for April 1st, the snow water equivalent anomalies in the western US. And you can see definitely in the northern part, in that Pacific Northwest and into Montana, usually we expect during La Nina those snow water equivalent anomalies to be definitely on the wetter side. So we'll see what happens. As Karen said, we're not doing great in snow quite yet, but we've got quite a bit of winter to go. So I have to give you a disclaimer here. All of the new outlooks from the Climate Prediction Center will be coming out on Thursday, but we do this webinar earlier in December just because it would be too late, probably a lot of people on vacation next week. So we do this a little bit earlier. So all my forecasts and outlooks that I'm going to show you are dated, but I don't expect a ton of change to them actually, because what they're using for the basis for these is trend, soil moisture, and so La Nina. So I don't expect huge changes to occur. But basically, precipitation there is on your left, and the forecast for the January, February, March season favors above normal precipitation for a good portion of the Pacific Northwest. But as you move to the southern part, it's equal chances, which just means our forecasters, the tools really aren't telling them anything that's giving them high confidence to say one way or another. So there's equal chances in those areas in the southern part of the Pacific Northwest. As you move into temperatures, most of the Pacific Northwest favors below normal temperatures for the January, February, March season. And moving into the drought outlook, the monthly drought outlook, which is on the top, was updated on the 30th, and it's favoring drought to improve or be removed with the kind of that khaki green color altogether. And so the seasonal outlook, which is the one on the bottom, that one will actually be coming out with the seasonal package this Thursday. So check back for that. But basically that one is also showing a good amount of improvement. Some areas remaining in drought and some areas will be removed altogether likely. Definitely keep an eye on the shorter range forecasts at the Climate Prediction Center. This is the 8 to 14 day temperature and precipitation outlooks. I've highlighted in those red boxes where you can find the weeks 3 and 4 and the 6 to 10 day outlook as well. Also, over there on the left, I've also put a red box for the week 2 hazards, and that goes through and shows you where there's slight, moderate, or high risk of hazards related to temperatures, precipitation, snow, or wind. So definitely keep your eye on those as we move through the winter months. So in summary, we are in a La Nina. Conditions are present out there. As Karen mentioned, we haven't seen La Nina actually has not been the big driving force in the climate system lately. We've seen a little more of our weather patterns being influenced by the positive Arctic oscillation. But we do expect La Nina to become more of a dominant driver coming up in the next few months. The tropical Pacific and the atmosphere are both very consistent with La Nina conditions, and we're expecting those conditions to go through the spring of this year and then transition to ENSO neutral. So check back Thursday on the Climate Prediction Center website for all of the new outlooks and forecasts. Thank you. God, my voice held up there. Thank you. I'll turn it back to you, Britt.
Thank you. And as I'm switching presenters to our next presenter, Megan, I think there's a pretty cool question in the chat, in the question box, if we want to give Andrea a question here as we transition.
Yeah, sure. So this is Megan Dalton from OCRE. So the question is, as sea surface temperatures are changing with climate change, are the absolute SST thresholds for La Nina also changing?
Oh, they do update those thresholds on a constant basis. They update their thresholds every 5 years, the climatology with that. So yes, I would say that is getting definitely put into the picture with you know, again, they do it every 5 years as opposed to every 10. So yes.
Okay, thank you.
Great. Next, we have Heidi talking about smoke-ready communities. And Heidi, did you get the ability to take over presenter mode. I'm not hearing you. I think perhaps you're muted.
Hi, I apologize. My computer is trying to restart right now for updates.
No.
Terrible timing. I'm not able to share the slides unless I quit and restart. So I'm wondering if Britt or someone else might be able to run them for me. I apologize for this.
No worries at all. Yes, give me 1 second. I will
Thank you.
take it back here. Yeah, no worries. And it will take me a second, but let's get these up.
And I can also just start talking while you pull those up, if that's okay. So
Perfect.
I apologize for the technical difficulties. My computer decided today was the day to restart everything. So my name is Heidi Huber-Stearns. I'm at an applied research program called the Ecosystem Workforce Program at the University of Oregon. We do a lot of applied social science, natural resource type of research in the Western US and in other places as well. So I'm presenting on behalf of a collaborative project that we have with Oregon State University, which is on the smoke-ready communities. If you'd like to advance to the next slide, please. And so I'm just going to talk briefly about what smoke-ready communities is and the point of it for kind of what the need was that we saw. And so I think maybe, there we go. So this is a little bit of animation here, but we can just click through these. So this project was convened by Oregon State University Forestry and Natural Resources Extension as a group project. They essentially identified this need for understanding how Oregonians access information about smoke, primarily from wildfires, what mechanisms and media would work best for Oregonians trying to access information about being impacted by smoke, and then to what degree the resources we have so far meet needs or not. Wildfire smoke is an increasing concern for communities in Oregon and other places as well. So this group focused on networking and kind of needs identification in 2021, and then moving forward, really what we've turned into is this kind of community of interest where public health folks, some environmental quality staff, researchers, and other outreach communicators, other educators can routinely connect. So we meet every 2 weeks or twice a month. And we've now really turned to focusing on reviewing the existing materials that are out there about what to do during a smoke event. So that's everything from how to protect your home or your family to working conditions, as well as things like, can you eat vegetables from your garden after a smoke event, and what are kind of the procedures for washing or otherwise dealing with that. And so we're reviewing existing materials. The goal would be to develop some new materials, essentially taking information that's out there and creating some information for communities that's, and by communities we mean kind of the general public, folks that are looking for information primarily through Extension that's doing a lot of this work already in the state around how to respond to wildfires. And then really thinking about what are some of the processes we might utilize for using what tend to be more preferred media and outreach mechanisms for providing this information. So what's the most effective way to share the information out? Next slide, please. And so as part of this work, we have, one of the things that came out of this group is a survey that we at the University of Oregon have been leading that's been funded by the Oregon Health Authority, which has been a survey of, it ends up being about 1,200 respondents across Oregon to understand, we oversampled for rural and urban, so it's about half rural respondents and half urban respondents, and trying to understand how they experienced smoke events in 2021. And at this point, we also had smoke events in 2021 and 2020. The survey was really focused, because we ran it earlier this summer before smoke events, it was focused on what happened last fall in Oregon. And we're in the middle of putting this report together that we anticipate will be done in pretty early 2022 to share around these questions around how people responded to the smoke, what kinds of protective measures did they take or not, what information did they have that they found useful and where did they get it, what kind of information did they wish that they had that they couldn't find or wasn't accessible either in language, format, medium, these kind of other reasons for not being able to access that information. And so we're using the smoke survey results and some of that information to inform what we're trying to do with our Smoke Ready Communities group more broadly around reviewing resources and identifying what types of resources might be useful or information for sharing with folks about wildfire smoke responses. And so then the other thing that I've been tasked with on behalf of our group here today is to just share a little bit about a couple related grant opportunities. One is Oregon DEQ Smoke Management, and the other is Oregon Department of Forestry Small Forest Land Grant Program. And so on the, I'll present a little bit about those here. And so the next slide, please. So just briefly before I end, and I'm happy to put some of this in the chat too if helpful, but some questions we wanted to pose to this group, you know, recognizing that we're a little bit of the outlier here as far as we're not providing necessarily you know, research or predictions right now. We're really asking for, we have some questions around if people have go-to sources for information on smoke, you know, around management or health issues or home hardening that we should be including in this review process that we're going through to identify, you know, kind of current resources that are out there, or if there's any specific smoke-related educational materials that people would like to have that they can't locate. So really understanding what do you use that you find useful, and are there other things that you might have that you can't locate? So feel free to reach out to me as well as the folks listed here with any of that information if that's of interest. And like I said, I'm happy to pop that in the chat as well. And then I'm just going to end on a couple of these, a little bit of information about these two grant programs on the starting on the next slide. Thank you. So this one is the DEQ Smoke Management Grants. You know, they're really trying to drum up a bit more of a concerted response to some of these grant opportunities that are out there. This is specifically for proposals that demonstrate alternative burning techniques or non-burn treatment options to reduce wildfire hazard and improve air quality. Several of these grants are ending, you know, in the next few days, but I will say that it's my external observation here is that it seems like there's definitely, it's definitely worth applying to some of these. They are looking for more applicants. So this is the first one. And then I think the second one, we might have it out of order here, but the second one is the Community Response Plan. And this is for local governments to develop comprehensive community response plans for smoke. There's, of course, both of these have websites. I can pop those in the chat too on more information about these, but these are, again, due on the 17th of December, but really kind of an important component to how communities are responding to wildfire smoke. There's several templates for some of this work as well to help develop these grants. And then we have a third grant opportunity here around small forest land grants. And this one is through Oregon Department of Forestry. And this one is really focused on reducing the risk of high severity wildfire through reducing hazardous fuels. So this is for small forest land owners that are looking to reduce wildfire risk on their property. And to some degree, you know, there will be a prioritization of watersheds that are at somewhat higher risk. They are welcoming all to apply. So again, I'll put all three of these links in the chat for people if they're interested in this information. And then just as a quick summary, I talked briefly about what Smoke Ready Communities Group is. We have this survey that's coming out that'll help tell us a little bit more about how Oregon residents both experience smoke and what information they'd like to have moving forward and how. And then please do reach out to either myself or John Punches, who is leading the Smoke Ready Communities Group, if you have questions, resources you'd like to share, would like to join us, any of that. And I will stop there. Thanks so much for the time and the opportunity.
Great, thank you, Heidi. And if you have any issues putting stuff in the chat box, you can feel free to email it to me and I can do it, but I think you're able to.
Thank you.
Thank you for that. And we have our last presenter is Chris Gomans, and I'm going to go ahead and hand off presenter control to him.
Thank you. I assume you can see everything?
Let's see. Yes.
All right, great.
So,
thank you for having me here today. I wanted to talk about some work that has been done by myself and some other colleagues at CSU, Dale Manning and Jesse Burkhardt, as well as somebody from your guys' neck of the woods, Alex Moss at University of Idaho. And this is some work that we've been looking into for the past few years, trying to estimate the impacts of droughts on a variety of sectors across the Western United States. Really quickly, some motivation for how we came to this point and what we were hoping to accomplish. First of all, in 2011, the state of Colorado came to those of us that were at CSU and asked us to do a drought impact study. And We did a combination of input-output modeling exercise together with a survey. And then 2012 happened and they came to us again, and we had to reset up the survey, reset up the economic model, and do the analysis again. And then we had a few years off, and they came to us in 2018 and wanted us to do a similar study. And we were kind of a little bit torn because we wanted to help and do the analysis again, but we felt like each time we were just doing the same thing over and over again. And we were also always talking about the possibility of being able to extend our analysis outside of agriculture. Previous work has largely used kind of these large structural models where we have a shock to agricultural productivity, and then we try to look at those impacts to productivity in the agricultural sector and how they trickle through the rest of the economy. There's anecdotal and other evidence to suggest that other industries are impacted, and it goes beyond the economic impacts as well to impacts to health potentially. There's a considerable amount of literature coming out now that shows how climatic conditions, air pollution impact health and criminal activity. And so what we really wanted to do was, for this new study that was going to focus on 2018, was to expand the scope of impacts and develop a generalizable approach to estimating the impacts of past, current, and future droughts, so that we could not only do this analysis relatively quickly without having to purchase all new data, but we could also move the analysis to different geographic scales and scopes and compare past droughts to current droughts, et cetera. So with this in mind, I want to show you a couple of things that highlighted the differences to us between 2012 and 2018. So I'll explain later why we use this categorization, but this is a map of 2012 on the left, the number of months with a PDSI category that we classify as extreme, and I'll explain that to you later. And just to give you an illustration of where we were focused on, it was southern Colorado for 2012, and in 2018, this is the same thing. We're looking at the number of months which we categorize as extreme drought based on PDSI, and this is 2018. So the difference largely being out in southeast Colorado, we had relatively less severe conditions in 2018, and in southwest Colorado, we had much more extreme drought conditions relative to 2012. If we move to temperature, which is also accounted for in our modeling efforts, we see that 2012 was a much warmer. If we looked at the precipitation numbers, it was much drier as well. And this is despite the fact that in 2018, we were talking about that drought as being just as severe and just as extreme. We noticed a difference between temp, precip, and PDSI numbers. So that's something to keep in the back of your head as another motivating factor. Each drought that we were being asked to analyze was very different spatially throughout Colorado, and we wanted to be able to incorporate that into our analysis somehow. So what was our basic research question heading into this? Overall, we wanted to answer the question, what impact does an additional month of PDSI category X have on outcome Y? So we wanted to think about this beyond just the impacts to agriculture, which we had focused on previously. So we're going to do a statistical exercise, collect lots of data. We're going to use county level data, annual and sometimes monthly, from 1980 to 2016. And we're going to come up with a variety of outcome indicators. For example, in agricultural productivity, we look at yields, total production, acres planted. For employment and other economic indicators, we use number of jobs, total wages, number of businesses. For health outcomes, we look at deaths associated with opioids, heart attacks. We look at taxes, a long list of different outcomes that we are interested in seeing how or if they respond to climatic conditions. So we use that as our left-hand side variable in our statistic analysis. And then the first thing we do is take historical PDSI numbers and we bin them, depending on whether or not, as we define them, as extreme drought would be the number of months over the course of a year where the PDSI number is less than -3. Moderate drought would be -3 to -1. And then we have moderate wet and extreme wet defined as how they're listed on the screen. One nice thing about this approach is that we're also able to see how different indicators vary depending on what, not just drought, but whether or not we have moderate to extreme wet conditions. So these categories here, the analysis isn't overly sensitive to them, but we chose them based on, or loosely based on, how Colorado is defining drought according to its drought plan. In addition to including the PDSI bends, which that coefficient estimate beta K, which is what we're estimating, is going to identify a % change from normal. So each month of extreme drought, the beta K is going to tell us the % change in the outcome indicator associated with a month of that type of category. We also include temperature and precipitation nonlinearly, so we can kind of identify how each of these outcomes respond to deviations from temperature and precip that are near the mean, as well as extreme deviations, which we might see during periods of extreme drought. Importantly, our analysis focuses on rural counties throughout the entire Western United States. So we didn't include Denver and Los Angeles and those types of counties, given that one of the primary motivations was to examine agriculture and then extend the analysis from there. So looking at some example output, and so we have something similar to this for each of the outcome variables that we consider. This is for corn production, and this is what we call the average effect of a month of each of these PDSI categories on corn production. So this is the average effect across all areas, all counties throughout the Western United States that's rural. And it suggests that for a month of extreme PDSI, which again we classify as less than -3, we see about a 3.2% reduction in corn production for each month. We also do some tests to look at how this average effect varies across either different regions or different times of years. An example of this is we split those bins into whether or not they occur during the growing season or the non-growing season. And not surprisingly, we see that drought conditions, extreme drought conditions that occur during the growing season lead to a larger reduction in total production. And we get that for yields as well. We do this for corn on the agricultural side, wheat, sorghum, and hay. I'll give some summary results later, but the most sensitive crops to these drought conditions are corn and wheat. Okay. We also do this for splitting the counties based on whether or not they are groundwater dependent or not. And we see that counties that are don't have access to groundwater are more sensitive to these climatic changes. So the point of this was to come up with a method to where we could essentially do for a particular year's drought and particular county, we could come up with essentially drought impact profiles. So based on the regressions that I was just showing you for each of the categories, we then look at the actual effects, including both PDSI, temp, and precip for a given year. So this is for 2018, and this is suggesting that this is a proportional impact. So hay production, for example, due to the climatic conditions in that year, we saw a roughly 8% reduction in total production for hay, and that effect was statistically significant. Similarly, we saw for hay a roughly 4% reduction in the total number of acres harvested, and that was statistically significant. Being able to differentiate between the impacts of total production and harvested acres are important, especially when we think about those backward linkages in the economy, which are driven by a reduction of inputs into the production process. So if the total number of acres harvested or the total number of acres planted is reduced, that signals to us that there's a reduction in the inputs that are utilized, and those backward linkages are likely to be stronger. Again, we just didn't look at agricultural outcomes. We also looked at employment impacts to the overall economy. In 2018, and this is for Otero County, we saw that the drought conditions led to a roughly 1% reduction in overall employment, and that was statistically different from zero. And but it did not lead to a statistically significant decrease in total wages paid for the overall economy. It did, however, lead to a roughly 3% reduction in recreation and entertainment total wages paid. That was statistically different from zero. Just to give you, again, an idea of the range of outcomes that we look at, we also look at crop insurance payments, the amount of liability that's paid out, the number of policies that are paid out, as well as the impact of taxes and revenue. So for each of these impacts years or impact county years, these drought profiles that we're doing, we get this complete list of impacts across all these different sectors that identify what's been impacted and what hasn't based on that year's PDSI, temp, and precipitation. Lastly, just to kind of summarize some key findings, there's a longer list of these in the reports. Again, our goal was to develop a temporally and geographically generalizable approach to estimating the drought impacts across a wide range of economic and non-economic sectors. We don't each year have to buy new data and generate a new model. We can carry this over from just having updated PDSI, temp, and precip. So for agriculture, focusing on those, we find that higher temperatures and precipitation have a positive and statistically significant impact on total production. However, those effects are diminishing and they become negative for conditions well above the mean. We find that each month of extreme drought conditions are associated with a decrease in total corn production of 3.2% and 3.6% respectively. Interestingly enough, our co-author Alex Moss sent me NAS numbers from this year, saying that wheat production was down about 47% per acre in 2021 in Idaho. And Washington, if you look at our model, we project about a 42% reduction in per acre yields. So pretty close to the ballpark. We find that drought conditions that occur during the growing season have a much larger negative impact on total production than the non-growing season. And then if we look at employment, wages, and number of establishments, we find that severe drought leads to a small but statistically significant decrease in the overall number of businesses. And it's largely driven by reductions in the recreation and entertainment, as well as the agricultural supply and trade sectors. And then for ag supply, fishing, hunting, each month of extreme drought is associated with a reduction in total wages of approximately 1.2% and 0.5% respectively. Lastly, each month of extreme drought reduces wages in the broader recreational and entertainment industry by about 0.59%. So if we're looking at 12 months of extreme drought, we're talking about roughly 6 to 7% reduction in total wages paid for that county. And with that, I believe I'm out of time, and I'd be happy to discuss this with anybody offline. Thank you.
Great, thank you. And while I turn it over to Megan and put up the speaker's contact information, I just want to apologize to Heidi. Even though she tried to correct me a couple of times, it didn't quite get through. She's not Oregon State University. She's the University of Oregon. So my profuse apologies, Heidi. Megan, do we have any questions?
Yeah, a couple. Chris, on your results slide, there was a question about the understanding the meaning of the sign of the horizontal axis, whether it's -3 or 3. There seemed to be a bit of a discrepancy. Maybe you could help clarify.
Oh yeah, I noticed that as I was talking, but knew I was running short on time. That should be PDSI less than -3. So that's the what we classify as extreme drought for our model. So less than -3.
Okay, thanks so much. Next question is, did the crop impact analysis take into account the farmer's dilemma, that is lower overall regional yields equals higher prices, or higher overall regional yields equals lower prices?
So since the analysis is at a county level, we wouldn't expect, it's a pretty it's as close to a perfectly competitive market as we can. So an individual producer, we wouldn't expect to be able to alter prices throughout the entire region. But this is purely an empirical analysis where we're looking at how an exogenous climate shock impacts corn production, yields, and acres planted. So there isn't a behavioral modeling involved in this.
Okay, thank you. There's another question related to groundwater. Given that groundwater is vital to meet the water demands for both consumptive and non-consumptive uses, what impact does an additional year of groundwater drought index category have on the outcome?
Yeah, so the statistical analysis requires that our right-hand side variables be exogenous. And so we couldn't use contemporaneous groundwater levels because then we've got this circularity where areas that might have low groundwater could be because they pumped it a lot when there was a drought and vice versa. So the way we do that analysis is we look at pre-period groundwater levels, so prior to 1980. And we look at, so these areas that have tended to historically had access to groundwater versus those that don't. So the reason our simulations are based off of just these average coefficients and not on the are you a groundwater area or not is because we're confident that our findings suggest that these average effects differ depending on if you're an area that have access to groundwater versus don't, but we're not as confident in the specific numbers. If hopefully that makes sense.
Thank you. And that's all the questions that we have.
I'd say something similar is true of irrigated versus non-irrigated crops because we don't have good data on those numbers. We kind of get an average effect again.
Great. Thank you so much to all of our speakers and all of our participants for joining this month. Mark your calendars. Our next webinar will be February 28th of 2022. And so happy holidays and happy new year to all. And we will see you next year.